I'm a structural engineer. I've got a practice in London, quite a small practice, but we work on nice, small, interesting projects usually, occasionally bigger ones. I'm here, I guess, because of my experience with glass engineering, which started in 1989, with a couple of architects who were desperate to do things with glass, which nobody else was keen to look at, to be quite honest, but we were very can-do kind of engineers. So we pitched in there and started on a journey which I had no idea that we were going to be on, but which was the most interesting thing that I've ever done, because exploring something for the first time hadn't been out there in the public domain. Of course, all the companies had their information, but they were very much like I'm not telling you, because it's my intellectual property. And the idea that the strength of materials could be in someone's private domain and not shared was incomprehensible to me. I really thought, wow. But, that's how it was with steel and concrete in 1900. So, materials have their moment. Going on, the very first project was with Eva Jurikna, who's a wonderfully kind of adventurous, talented, basically mostly interiors. And she was always going on about building a glass staircase. And, none of us wanted to satisfy our demands because we were engineers. And that's not what you did, Even our own staff, where you don't build a glass staircase, that's crazy. But she wonderfully insisted, and she had very beautiful almond eyes, and you couldn't resist her, She's like, okay. So as well as satisfying the architectural whim of the architect, you were satisfying the sort of charm and irresistible persuasion of this woman. So that's what it takes, I think. It didn't come from my soul, I didn't think, I want to do this. It came from her wanting us to do the first staircase, and it was, in the end, wonderful, because that was the first time we questioned. We said, we did go to the big companies and say, how do you do this? And they said, you do it this way, like big metal frames around the glass. And she didn't want metal frames. And we then started asking the questions, how strong is this stuff, How do you calculate it? How do you make it safe? So we were actually opening up the questions that really hadn't been asked properly. The industry did its thing, it provide a warranty, as the glass falls from the sky. Hey, where's your warranty? That was Pilkington's 1995. The glass on Waterloo Station, single sheet, toughened glass, falling 12 meters. Nickel sulfide. They were saying, that bird dropped a bolt onto the glass. What? So the whole industry was not controlled. And then you realize, what's your job? What's your job as an engineer? What is your job? Your job is to actually negotiate between, if you like, the market and the client. You're supposed to be like the person with some sort of moral integrity. Money isn't the goal. And people's over-ambitious, overzealousness has got to be under control. So that's your role, Suddenly you realize it, With steel and concrete, you're doing it all the time. You don't even know what your role is. You're doing it, You don't understand the role. But here you're given completely new material. And you've got to say, from first principles, this is how it works. This is, here are the ways we think about it. And so that was the great beginning, if you like. And she was followed by Rick Mather, who was also, in a different way, totally intrigued by the idea of using glass. His was without connections. Hers had a lot of beautiful stainless steel pieces, so it was very baroque. His was very modernist, very clean. And so you had these two things going on as well. Trying to solve problems, without the metal bits, and trying to solve problems with the metal bits, design the metal bits. So they were the two who set us off on the journey. And the thing is, once thing gets published, right? It's like you watch this with cast glass. You know, Herzog and de Meur on a big project in China just now gets into publication. Suddenly everybody wants to do cast glass, you know, which is what happens. Same happened with the structural glass stuff. You know, as soon as Eva's staircases were there, they're there. You know, they're actually there. So yeah, we can do this. And downstream, you get all the architects. Can I have one? You know, can we? So that started the process. Well, it's unique in the sense that it's been around forever. So it's not unique at all. You know, it's like, it's such a kind of well-known material and well-used material ever since it was first kind of dug up in 500 BC or whenever they started making little jars or whatever with it. And I mean, what I find magical about it is that I love to clean my windows in the house, you know, because it's such a kind of forgiving material. As long as you don't deeply scratch it, you know, it can be there forever. And I just love, I mean, we've gone on to make these enormous bits of glass I was showing yesterday in a slide, a 20 meter long. It's an enormous piece of glass. The question I always ask, what happens if it breaks? I don't, yeah. You've got, I mean, come on. Is that sensible? I don't know if it's sensible, but it's fulfilling the architect's, really the client's desire there. I think even the architect was a bit nervous about it. But what I love is to go home and there's a wee window about that size, you know, and it was made from someone blowing a bubble and flattening out as a plate and then cutting a bit of glass out of the plate. Magic. You know, 3 millimeters thick. And it is just a beautiful piece of material. And with that, you can keep the wind out, you know, you can keep the rain out. Then, of course, you start asking complex questions like, how do you keep the heat in? How do you keep the heat out? So if you're in Switzerland, you have big wooden shutters, that keeps the heat out. And in the winter, you have secondary glazing you put up in its own frame and create a big cavity, but, you know, you create, you know, you can stop the heat going out to some degree without doing anything else. And that's kind of magical. I mean, we're trying to replicate that in sophisticated technical ways, but there's a penalty, okay? And the penalty is that, firstly, the versatility is lost to some degree. You know, you start becoming at the mercy of what someone can make. Brilliant, they can make these big things, but is it sensible? I don't know. It's a question, you know. I mean, it's wonderful to know that someone has developed a way of doing it and making it. But there's a what for question, you know, and should we be doing that, really? So there's in the whole environmental question, which always emerged when I gave a talk, was, you know, have you thought about the environment? No, we're just thinking about the structure. But now we're being forced, you know, otherwise the world will burn up or something. You know, you've got to think, you know, are what we doing as sensible as we, you know, are we not just pursuing some sort of vain thing for other reasons? I can do, you know, I think bigger than you kind of thing. So in a way, the beauty of the simplicity of the simple single piece is still magical for me. Anything else that you add to it is okay, gives you another function, but you're introducing, you know, you laminate, you put a piece of plastic between the two bits of glass. Mm-hmm. You've got to take it out again when it breaks. Is it reusable? No, because you've toughened it, you know, you can't cut it. So I'm kind of thinking now back into, I thought it'd be a nice study for someone here, anywhere, to sort of look at the light transmission of, you know, particularly in Holland, you got these great big windows, you know. You know, everyone kind of looks in, you can look in at what everyone's doing in there. It's a Protestant thing I heard, you know, so you don't get up to any nonsense in your flat because the people in the street can see what you're doing. Big window. So Holland's had a fantastic tradition of big bits of glass, and I bet they were float glass in the beginning. I bet they weren't toughened glass. They were just big bits of float glass, I think. So all very kind of reusable and adequate enough. How much light goes in that window versus, you do a sort of triple ply laminate, 12-meter high bit of glass with coatings, and by the time you've done all that, I wonder how much light comes through that, right? So those kind of questions I think would be worth revisiting so that we can maybe also get back, at least to some degree, to some level of simplicity that you begin to feel morally good about, let's say. Keep an open mind and love life, Combine those two things together, and you might get a nice chemistry, you might get a nice result, But there are a lot of things that are wonderful challenges out there. We don't even know what they are, of course, because we haven't encountered them yet. But for students, you've got it, It's not handed down by bloody AI, It's in here, right? It's not out there, it's in here. And that's what it comes, to be a human being, to fulfill yourself in life is not about how clever you can get a GTI to write a paper for you. It's actually about what you bring out of you in whatever form that is. And the more intelligent, the more curious, the more questions you ask, the more fun. More fun, For students, make sure you have fun. I mean, don't get pissed every night, but, well, you can if you like. But the main thing is that you enjoy it, enjoy the curiosity, enjoy the journey. It's all about a journey. And that's that. You're not a cog in a machine. You're a thinking, intelligent, even the person with thinking they got the least amount of something, they've got something, and they just got to find it. That's your journey. It's your journey as a student. It's your journey as a human being. So my advice to students,